Hi, I'm David Peacock, and today we're going to talk about exponential and log functions. Timber! Exponential and log functions. Well, a logarithmic or log function is the inverse of an exponential function. In other words, if you had a variable in the exponent and were trying to solve for that variable, you may use a log function in the solving process. Now, we can use the following rule to convert between a log function and an exponential function. Log base b to the m equals n is the same as b to the n power equals m. So basically log is the relationship between two numbers. So like if I say the relationship between 5 and 125, that would be that it's 5 cubed. So log base b of m would be, if it was log base 5 of 125, it would be 3. Or if it said b to the n equals m, we would say 5 to the third power equals m. So now let's try it with 5 squared. So b in m. So this becomes log base, in this case our b value is 5, of 25 equals 2. So 5 becomes 25 when you square it. Let's try another one. So in this case, b in m, this becomes log base 10 of 1,000 equals 3. And we move, what is that? Oh, it sounds like there is a bonus little fact here. So if we have a log base 10, we can actually just write that as log 1,000 equals 3. So remember, log base 10 is the same as log. Alright, so now let's try this. 729 is 3 to the 6. Now, this might throw you off because you're seeing 729 first, but remember, it's still going to be b to the n equals m. So, log base 3 of 729 is 6. Alright, here's our last one. Oh, look, it's our buddy e that we talked about last class. So that's our base in m. So we would write log base e of 7.389 equals 2. And that's about, again? Yep, that's right. So if we have log base e, we can also say Ln for natural log. It's actually a Latin phrase that means natural log. So Ln 7.389 equals 2 is the way we'll normally write this. Now let's try switching from an equation in log form to exponential. So let's see, b m n. So this becomes 2 to the n power is 3 equals 8. Here we go. Remember our base is this, so it becomes 10 squared is 100. All right, remember this is the same as log base e, b m n, e to the 1.609 equals 5. Ooh, that looked like a 0.5, so let's try that again. Equals 5. All right, b m n 5 to the 4th power equals 625. All right, now we're going to actually evaluate some logarithms. So in this case, remember, this is like it equals x, and that's what we're looking for. So I would rewrite this as 4 to the x equals 16, and I hope we all realize that it's 4 squared is 16. Let's try this one. 3 to the x is 1 over 9. Now, if we remember from our last unit, when we talked about negative exponents, a negative exponent will move it to the denominator. In this case, we know that 3 squared is 9, but it's in the denominator, so x has to equal negative 2. Okay, so this is 9 is 27. Now, here's one that's a little bit harder because 9 squared is actually 81. But I do know that 9 times 3 is 27, and 9 is 3 times 3. So wait a second. Those are all 3's. So if I square root 9, which means x is going to be equal to 1 over 2, but then cube that number, so 3 times 1 over 2, I end up getting my answer of 3/2. And finally, we have ln e to the 6. So remember, this is really log based e times of the e to the 6. So in this case, what we know is it would be e to the x, that's what we did every other time, is equal to e to the 6th. Now, I don't know what e to the 6th power is, but I don't need to, because I know that x is going to be the same as whatever power I'm raising e to, so x equals 6. All right, now let's find the inverse of each logarithmic function. So, to find the inverse, what we have to remember is, in the inverse, we switch x and y. So this becomes x equals log based 5 of y. Now, the thing is, I want to have y by itself, so the way I get rid of it, and you might remember this, if I'm is to use the inverse equation. The inverse of a log is an exponential. So I'm going to just rewrite this as 5 to the x equals y, or y equals 5 to the x, as I would like it to be at the end. Now let's try this one. This becomes x equals log base 2 of y plus 3. So in this case, because y plus 3 is all being dealt with as a log, we end up first having to do the exponential. So 2 to the x equals y plus 3. Now I want y by itself, so y is going to equal 2 to the x minus 3 when I subtract 3 from both sides. Okay, and now let's look at this one. Remember, this is really log-based e, so x equals, I'm just going to rewrite this as log e x plus 7. First step I would do is subtract 7 from each side. X minus 7 is equal to log base e of x. Sorry, I've been writing x both times when this should be y. At which point, e to the x minus 7 equals y.